do this problem, although I may not find the complex power for each element, just in the interest of time. And I might switch it up a little bit and do a source transformation so that we have a current source instead of a voltage source. So let's do that. And we'll keep the same values so I can check my work. Okay, so R2 is 500 ohms. L is 0.5 millihenries. Our capacitor is 0.1 microfarads. R1 was 100 ohms. And if we did a source transformation, then our current source would be our voltage over the resistance, so that would be 0.4 cosine 10 to the 5th t. So if we change this to all phasors, then our inductor will be J omega C. Now omega, we get this from here, so if our original voltage was 40 cosine 10 to the 5th t, then omega is 10 to the 5th. Now keep in mind, if I had been told that the frequency was 10 to the 5th, then omega would be 2 pi times 10 to the 5th. But here, since I was given the equation, I was just given omega. So this is J times 10 to the 5th times 0.5 times 10 to the negative 3rd. This is still 500. Our capacitance will be minus J over omega C, or minus J over 10 to the 5th times the capacitance is 0.1 times 10 to the negative 6. This is still 100, and this will be 0.4 angle 0, because we don't have any additional phase in there. So now I would like to get the voltage right here, because if I have the voltage and the current, then I can find the power. So I'll do node voltage. Let's make this 0. So from my current source, I have minus 0.4 plus from this first resistor V over 100 plus from the second resistor, from the capacitor, V over minus J over 10 to the 5th times 10 to the negative 6 times 0.1, so that's 0.1 times 10 to the negative 1, plus V over 500 plus J times 0.5 times 10 squared, and all that equals 0. So this is minus 0.4 plus 1 over 100 V plus 0.1 times 10 to the negative 1 is 0.01, and then I'll take the reciprocal of that, 0.1 over minus J times V plus 1 over 500 plus J 0.5 times 150 V equals 0. Now I will use some calculator help. So 0.01 divided by minus J is 0.01J. Oh, I knew that. Minus 0.4. 1 divided by 100 is 0.01. So this is plus 0.01J. Now let's get one divided by 500 is J50. Plus 0.0019 802 minus J 0.000198 equals 0, and this was all of these were times V. Okay, so now I can add together my real parts and my imaginary parts, and I'll take the 0.4 to the other side. Some people might prefer to do this all in favors. And then, so this would be 0.0198, that's this part and this part, minus, let's see, 0.01 minus 0.000198. So about 0.01. So plus 0.01J. V equals 0.4. So now I want 0.4 divided by that. And I'll convert that to polar. And see if I got the answer I'm supposed to get. Looks like I just made a little error here. This should have been 0.01198. So let's try that again. And convert that to polar. And that's the right answer. So V is 25.6, angle negative 39.8. Alright, so now let's say that I wanted to find the let's say I wanted to find the complex power, or if I wanted to find the average power for my current source. Well, I like just finding the complex power because if you have the complex power, then you have the average power and the reactive power. So the complex power, let's take a look at it. So the complex power is 1/2 V I conjugate. The real average power is V RMS I RMS times the cosine of the angle. Now, you want to be careful here. I see a lot of people forget about the RMS thing, so let me remind you about how that works. Hold on, let me just show you. So for sine and cosine, I mean, you did the RMS problem, or I did the RMS problem earlier, where you take the integral over the periods of the function squared. But notice in my complex power right here, I have 1/2 V I conjugate, or V RMS I conjugate RMS. The 1/2 comes from the fact that the RMS is the maximum divided by the square root of 2. Well, what's the maximum? Your phasor, that coefficient on your phasor, that's the maximum. So when I'm looking at, this is V, this is the max V max is 25.6. V RMS is 25.6 over the square root of 2. So if I wanted to find my complex power, I'll be 1/2 V I conjugate, or 1/2 times 25.6 angle negative 39.8 degrees times, you know what, since I'm doing complex power, I'm going to leave it in rectangular form. 1/2 times 0.01198. Oh, I never had it in, I never wrote it down in rectangular form, so never mind. So, 1/2 times 25.6 angle negative 39.8 degrees times I, well, I was 0.4 angle 0. And remember, when you multiply phasors, you add the angles, so this would be 0.5 times 25.6 times 0.4, 5.12, angle negative 39.8. Now if I change this to rectangular, take this, there it is, in rectangular. Now I want to take that times 0.5 times 0.4, and in rectangular that gets me 3.935 plus J minus 3.285. So my real power is the real part of this. So my average power, which is my real power, is 3.935 watts. Now let's see how that works if we do what it seems like people like to do, which is to say that it is VI cosine θ. Okay, remember these are RMS. So VRMS is going to be 25.6 divided by square root 2 times IRMS is 0.4 divided by square root 2 times the cosine of the difference of the angles between them minus 39.8. So divided by the square root of 2, and then another divided by the square root of 2 is the same as dividing by 2 is the same as multiplying by 0.5. And you see I get the same thing.